Hi, my name is Sean Wildermuth of Wilder Minds. This is the SignalR and ASP.NET Core projects by example. In this course, we're going to discover how to use SignalR in ASP.NET Core projects. This is going to include configuring SignalR, using hubs, integrating with the JavaScript API, strongly typing hubs, and working with users and groups. So what exactly is SignalR? SignalR is a .NET project that integrates with ASP.NET as well as ASP.NET Core. It's a server-client remote procedure call system. This allows clients to call into a server using RPC. Its goal is to give you near-time communication. And most importantly for most people, supports the idea of multicasting for connectionless clients. SignalR can certainly work with Java and .NET clients, but it's most used with a JavaScript client for either mobile apps or usually the web. It's really built for things like dashboards, collaboration, messaging systems, where you need that ability to call an API and then send messages across a variety of clients. Let's see what that looks like. In ASP.NET Core, when you use SignalR, you're going to create something called a hub. This is something similar to a controller in ASP.NET Core, in that it's going to expose a set of functionality. Essentially, it's a publish and subscribe model. So you're going to start with one or more clients, whether they be on the web or .NET or Java, and they're first going to register with the hub through a web-based API. Once they've done this, they'll get a list of those client IDs. So that if one of the clients calls into the hub with a message, the hub can then multicast it out to a variety of these clients. This is the central idea, to be able to send these messages to one, many, or all of the client IDs that are registered with the hub. This even works inside of the ASP.NET Core project, like in a controller. It can send that same sort of message, then that can be multicast out. How does it do this? It does this by utilizing a variety of transports, and this is going to depend a lot on where the client is being run, whether that's in .NET, whether that's in Java, or most importantly, again, JavaScript. So most notably, it's going to attempt to create a WebSocket, which is a connection from the client to the server to allow for bidirectional communication. But that's not always going to work. You have older browsers, you have security limitations, you have networking issues like proxy servers where WebSockets just doesn't work. And so if registering a client doesn't work with WebSockets, SignalR automatically downgrades itself to use long-living network requests, or COMET as it's often called. Again, in this way, it opens up connection to the server, but leaves it open so that the server can send it down. But this doesn't work in all scenarios either. So at the end, if neither of the first two transport works, it'll fall back to long polling. So underneath the covers, it will call to the server occasionally to see if there's any messages waiting. All of this is under the covers and nothing you, the developer, need to worry about. You just know that it's going to work in a variety of scenarios and hopefully in the most efficient one that the scenario is going to allow. In this way, you don't have to worry about or check with the user of your website or of your mobile app to figure out which one of these is going to work for them. It'll just try one. As it fails, it'll fall back and fall back. Let's go ahead and start using SignalR. We'll start out by just getting the starting project and looking at how it works before we bring in SignalR to see what problem we're really solving. In order to get the starting project, we're going to want to open up a browser, and we're going to want to go to github.com/wildermindscourses/SignalR by example. This will be the starting point for our project. If we look at this project, this Git repository contains the starting point for all of the examples I'm going to use. So if you're familiar with Git, you can go ahead and just clone the repository if you want. But if you're not, you can just click this green button and download a zip of the entire project and really put it anywhere you want. Once you do this, go ahead and just open up that folder in Explorer, and you'll see the callcenter.solution file. Just double click that and it'll open it in Visual Studio. This will also work inside of Visual Studio Code or Visual Studio for the Mac, but I'm going to use Visual Studio since that's probably what most of you will be using. Nothing we're going to do here is particularly centric to Visual Studio, but of course the exact way I'm going to create new files and such will be different. Now that we have the project open, this is a typical MVC project using .NET Core. Not a lot is different from what you might already be using. And really, let's go ahead and run it so we can see what we're trying to do, and then I'll walk through the project. So this is a very simple project. It has a help center where someone can put in their name, email, and a problem they're having, like a help desk. And there's also going to be a call center. A call center is a page that shows calls that are piling up from the help desk. And you could imagine making this web page eventually go ahead and handle the call, start a phone call, take notes, whatever the case may be. We're going to start really simply because effectively what we want to do is the people who are handling the calls, we'd like to be able to populate this with new calls no matter where they're happening without having to refresh the page over and over. For example, if we go here and I'll put in a new test. Of course, this is what 80% of the help center is going to be. I can't get my printer to print. And once we save that, if we go back over to the call center, it'll show this new item from Sean at AOL.com, right? But without SignalR, we're going to have to refresh this or do something, create a timer, refresh the page, whatever may be involved. But with SignalR, we'll be able to actually just make this page be able to react every time there's a new call somewhere to this website so that everyone looking at this page will get those updates. So back in the project, I'm going to assume you have some familiarity with ASP.NET, so I'm going to make this pretty brief. We have a quick database with just one entity called a call, and then a context object from Entity Framework Core. We have a simple set of controllers. We have an API controller called calls. Those are going to be used for traditional calls. This is where we're actually getting a list of the calls for us. And then a home controller that's going to handle most of the web pages. We could have done a lot of this with Razor pages as well, but I personally prefer MVC, and so that's why we're using it. Lastly, the views. We have a layout view, which just creates the Chrome for most of the pages. And we're really only going to be dealing with two pages, index and calls. These are two pages that have some functionality on them. The index page is just for handling that form entry and validation. Not a lot interesting there. But the calls page is just a simple table that has a JavaScript file associated with it. And in our example, because we're not going to get into how to use this by creating a spot and anything more elaborate than that, this is all actually written just with simple jQuery code. It's not a lot of code that makes the whole page work. And we're going to be augmenting this in order to bring in SignalR. Doesn't mean you're going to need to drop back into jQuery if you're already using Angular or React or Vue. We'll actually be handling that in future courses. But for this, we just want to show you the bare bones of what just JavaScript and HTML can do in integrating the SignalR project. So now that you have a bit of a sense of navigating what parts of the project are important, let's go ahead and create our first hub. Now let's go ahead and create your first hub. Back here in Visual Studio, I'm going to collapse some of this. I'm just going to open up the startup.cs because before we can create our hub, we're going to have to opt into using SignalR into our project. And there's really two pieces of this. The first one is to find the configure services, and we're going to add services.add SignalR. And we could just add SignalR, which is going to add all of the dependencies, but I'm also going to add a configuration lambda here just so I can turn on detailed errors. We'll probably want to actually do this later for production versus development, but I'm going to leave it the way it is for now, just because as we build this, we're going to want those detailed errors in case we do something wrong. The other thing you'll need to do is before the MVC routes is actually opt into this. It's important that you do this before use MVC, as use MVC has a finalization. It doesn't call middleware that occurs after it. So make sure you're doing this before. And here we're going to say use SignalR. And here we're going to use a lambda to configure ourselves. And here in the routes, we're just going to say, I want to map a hub. This is very similar to the way we do something like a map a route in MVC. Here we're going to give it the name of a hub, which we haven't created yet, but we'll come back and use this later. And I'll just call this my call center hub. And I want to give it a string that represents the URL to use as the hub, because this is essentially exposing an endpoint on your server that isn't RESTful. It's actually using a very specific API call to do remote procedure call. So I'm just going to call this the call center. You can call it anything you want. You could prepend it with API. What the string is isn't important, but this is a string that needs to be shared with the clients to know how to connect to the SignalR. This implies that we can map more than one hub, and that's absolutely true. You might have hubs for different kinds of applications. You could think of hubs as all serving the same sort of task, because one of the purposes of a hub is to keep a list of those connected client IDs that it can broadcast to. So you might have a hub that's for administration functions, or a hub for the sales force, or a hub for HR. I wouldn't try to put everything into a single hub unless you had a really good reason for it, but often one hub is going to be enough for some applications. Let's go ahead and create this new hub class, and I'm just going to do it. I'm actually using the add new file extension because this just makes it a little easier to create folders and files really quickly, and so I'll call this a new directory called hubs, and I'll call it the call center hub, and this is just a CS or C# file. This new class we're just going to derive from the hub class, and this is in Microsoft ASP.NET Core SignalR. And this class doesn't require a constructor. You could use a constructor for injection of any requirements, but we don't have any at the moment. And so all I'm going to do is I'm going to create a new public async action that returns a task, because we're not returning a value here. We're just going to send a message. You could certainly have it send a return as well. It's just not as common. And I'll call this new call received. In that case, I'm just going to pass in actually the call object. So what we're doing here is we're defining what sort of message can be sent. Be aware that that's really what we're doing here. So we're defining in the hub what things can be called and registered for messages to each of your clients. When we start to use the JavaScript client, this will be a little clearer. But we're effectively saying new call received is something that we can call. And what are we going to do here? We're just going to await and call clients, which is all of the clients that have attached to the hub at this point. And we could decide on picking who to call. We could call the caller, so call the same client that is calling us. Not as common. We can say all of the callers, which we'll do in this case. And later on, we'll look at sending it to specific users and to groups of users. And here we're just going to say send it async, and I'm going to give it the name of the message it's going to send out to all these people. New call received. It's not going to be uncommon that this name and this name are going to be the same. In fact, later on, we'll show you a way to get rid of the magic strings. And here we'll just pass in the new call that we're going to send back down to the client. And let's go ahead and fix this reference. And let's build it to make sure it works. And it gave us an error about the call center hub because we haven't resolved that name yet. Bring in that hub's namespace and build it, and we should have a clean build now. Perfect. So we've created our hub that we can connect to. So let's now call this hub from inside of our project so we know how to start the message sending process. Now let's see how to send messages from the server. Back in our project, let's open up that home controller, because this is actually where we're updating and creating a new call. So here's the post for the index, and this is where we're going to go ahead and add our new call and then make sure the changes have happened. And so what we want to be able to do here is call the hub to alert all the clients, right? We want to be able to do that. So how do we get at the hub? If we go back over to our controller constructor, we're going to add a new class called iHubContext. And we're going to give it the name of our call center hub. So this is an interface that's going to wrap our hub in order to give it a way to get at it. And because this is in the constructor, the dependency injection is going to inject to us a context to that existing hub. So bring in the namespace for SignalR, and we'll bring in the namespace for the hubs, and we'll call it the hub context, right? And I'll go ahead and use refactoring to go ahead and just create a local member for us. Could do all that by hand, but you can see everything we're doing there. And so we now have reference to this context that we can then fulfill our goal here. So we can call that hub context, and we're going to actually call the hub context and say clients all send async. So we're going to need to await after this. And what are we going to do here? We're going to do just what we did before, which is basically say new call received, and then pass in that model object, the data that was just created at the server, to let all these pieces know. Note that we're not actually calling the method called new call received. We're calling that contract that we've exposed in order to let that message be known. We're going to come back later and get rid of these magic strings, but this is essentially going to say, hey, I've successfully saved a new call. Let everybody who cares, everyone who has that page open, let them know about this new call. So now we've created a hub, we've handled the way to make that multicast call happen, but it's not going to actually do anything unless we have some clients. So this ends up being a fairly zero-sum operation if no clients have actually registered with it. So we're going to have to do that next, is actually register with the JavaScript API. So now let's add the client-side code. So back in Visual Studio, we're going to want to add the support for this into our JavaScript calls.js, because this is the JS file that is responsible for that call page that has the list of calls, right? This already has the ability to delete an individual call and, more important, to call an API in order to fill and add the calls to the page. It's doing this asynchronously once the page has been loaded. So luckily, this has a lot of the work we need to do to actually do the templating and the other things we want to do to make this work. So what we're going to want to do first is get the library that is responsible for it. So Microsoft has an open source library for JavaScript, and depending on how you're getting your client-side dependencies will change how you're doing this. If you're using a packages.json to do it, so you're using NPM or Yarn, you would add the project there. If you're just pulling them in directly, you could do it that way. But we're using libman, so we should be able to just come into the project and say add new client-side library. This is going to bring up this dialog, which some of you may have never seen before. And I'm going to use the unpackage system to look for a package called @ASP.NET/SignalR. And it tells it where we want to install it. So we're just going to include it there. We're going to, I think, need to use a version number. Yep, 112. We can see all the files. This is a little ancillary to the job at hand, but in the case of using the libman, you can actually decide not to include it all. So you'll notice that if we change this to choose specific files, we can actually decide we don't need the source, we don't need the package, we just need the browser part of the disk, because even these are for packaging this inside of builds of different sorts, ESM or CommonJS. But we're just going to bring in the browser version. I'm going to change this to just be SignalR because having both levels I don't think is necessary. Once we do that, you'll notice there is a new SignalR directory here with SignalR and SignalR min, right? Plus map file so we can debug it. So if we go back and open the view for our calls page, here we're using Moment to do some date work, and we have our client script. Before both of these calls, we're going to want SignalR. So I'm just going to drag it in so that we're bringing it in before calls. That way it's exposed to us in the client. Again, if you were doing this with Webpack or Browserify or one of those packagers, you would do this by bringing in that package into your build system, but we're not there. Now that we have that, we can start to use the API here. So now that we have SignalR in the project, let's go ahead and just create a new client. And we're going to do this by calling SignalR and creating a new hub connection builder. This is an object that will be able to build a connection for us. And then it's a fluent syntax, so we can then say, you're going to build the connection with the URL of call center, right? This URL is the same URL that we used here in startup as the URL to listen for that hub. So we're connecting to a specific hub on a specific server. This call could be an entire URL, could be an URL to a specific server, but because it's on the same server as our web page, we can use the relative URL. And then finally, we just called build to go ahead and create that client connection. This is going to be something that we can start communicating with the server and to receive messages from the server with. So now that we have the client, let's use the on call to listen for a specific message, and that's going to be new call received. Where did this come from? The new call received is the same call we have here in the call for new call received, or if you remember back in our home controller, we're using that same name here. So we're effectively saying, hey, when I'm sending this, send this message out, and when the client is called, it'll see the message name and try to match it. When it matches it, we're just going to say, go ahead and call me. And I'm just going to use a lambda here because it's going to pass into us a new call, and we want to actually do something with that data. When this object comes to us, it's actually going to be resolved into a JavaScript version object. So it's going to be the same sort of object that we would get from an API. we should be able to just call a method to add it to the table. And luckily we have a function already here called add call in our code that we're just going to reuse and call add call. This add call is being used by the JavaScript already to build up the table when it goes and gets the data from a traditional REST API. And so we'll just include the call we're being sent in so that it shows up on the page. The last thing we need to do is actually to start the client. We can do this after the API goes ahead and adds all the calls on the page, just so there's no confusion. And so I'll just call client.start. This will start listening for those messages. Because we just made a call to the API, there's a small chance that we'll miss a message in the middle. And you can certainly decide to do this in a different order, but this really helps us resolve it more simply. Now that we have all the code, let's go ahead and run this. And here I've run it in two browsers side by side, because what we're really talking about is being able to add a new item here and have it magically show up on everyone who's looking at this call log page. So if we refresh the call log page, you can see we're still getting those calls, but if we look at the output, we'll actually see some messages from SignalR saying, I've gone ahead and normalized the URL you used, and this is the actual URL I'm going to be using, and that it's using WebSocket and has successfully connected using a WebSocket call with the entire thing. This is debugging information for you. If we had used the release version, there's probably going to be much less of this, but this will help you know in certain scenarios whether it's actually using WebSocket or it's using long-lived connections or it's actually using long polling. It'll give you some of this information so you can debug what's really going on. So we know that it's connected successfully, right? Let's go ahead and add a new object in here, and I'll say it's from Bob Smith. And I'll give him a great email address that I'm sure someone actually has. And just say my printer doesn't print. Most help centers, that's most of the calls they get. If I press save, you can see it shows up right away. And this wouldn't matter how many of these I got, right? Jim Tomei, jim@angels.com. I am retired. Only you baseball nuts will get that joke. And when we send this, we'll get to Jim Tomei here, and it already did it here without us refreshing the page because it has this connection up to the server, and the server is going to send that message as soon as we make this change to some other part of our application. Now, it could be that the JavaScript code is making that call as well. But before I show you that, let's talk about the string problem and look at strongly typing our hub, which if you're uncomfortable with magic strings will be something you're going to want to do. Let's do that next. So now let's talk about strongly typed hubs. Back in our code, let's go to the hub itself, because one of the things we'd like to do is be able to figure out how to just make this call instead of having the magic call in our .NET code that knows about how to do all of this, right? We'd like to hide that detail, and it becomes more difficult to do this without some type safety involved. So it has a facility for this by having a hub that implements a class like a iCallCenter hub. So before we add that as a parameter, I'm just going to use refactoring to just extract an interface for us. And I'm going to call it the iCenter hub. And I'm just going to include this new received call that we have. And it by default makes it an interface that has to be implemented. But we could actually do it this way and just surround it with the hub. And this identifies this hub as adhering to that contract of the interface. So this is the interface. As you change this, you'll need to change this. And you'll notice once we make it strongly typed that it's complaining here because we don't actually have a send async anymore. Because by making this adhere to this interface, we're really telling it that we want to be able to use the strongly typed version. So anyone calling this would call it by invoking from a client to execute this code. But if you remember back in the home controller, we're using it to call this message. But this isn't strictly a client of it. It's some other part of the API. So we're going to have that same problem, but we want to use the type safety. So let's come up here and add as a second parameter to the hub context, our call center hub interface. We can do the same thing by adding it here. And that's going to give us the same problem we had before, but here we're going to be able to call the new call received without any of those weird magic strings, right? You're still not hiding who you want to call inside the hub in some way, but it is giving you a more strictly controlled version that can be compile time tested. This isn't going to affect necessarily what we see from the JavaScript or the Java or even the .NET clients necessarily, but using this strongly typed version certainly does help. So we come back to our versions. Let's go ahead and just reload these pages. Just make sure it still works. A lot of people still have their old AOL addresses. Printer issue, right? There we go. And it still works even though we've added type safety to it. Let's talk about groups and users next. Now let's talk about groups and users. In the JavaScript, we might want to designate that we're in a certain group. We might want to call the hub and tell it some information to subscribe to a particular group, not just to a message, but also to be in some smaller conclave of people that are going to be called. And so if we come down here, let's do it right after the start. It has to happen after the start because, of course, the start is an asynchronous call. So we can go ahead and just add a then here. So we've successfully connected. What do we want to do then? We want to use the client to invoke a call. And invoke is very much like what we're doing on the server. We're going to say join call centers, which will be a new group we're going to use. And we can also say send. So invoke and send look the same, but they're a tiny bit different. Invoke says call and wait for the operation to complete before returning. This is especially important if you're expecting some return value, which we're not, but you could certainly get a return value. Send tells the server that you need to execute it, but to return the call as soon as possible. And in fact, SignalR in that case will return before the operation actually executes. So you're not going to get error information about the execution of the call. So I normally use invoke unless I'm trying to do sort of fire and forget sort of semantics. You could imagine using invoke to set the red flag so that something can be marked as red, because the cost of that red flag being false on a couple of machines, if it did fail, is pretty low, and you don't want to necessarily worry about the success of that. But if you had one that was going to send a new message to the server, you'd want to invoke that to make sure it actually succeeded and that you knew whether it was actually added. So we need to have a way on our hub to actually implement this join call center. So let's open up our hub again. And what I'm going to want to do is create a new method here. And I'll use that same name, join call centers, right? There's not going to be any methods here. But of course, we're not going to be able to call this in simple ways unless we add it to our interface. So let's head over here and also add it here, task join call center, so that it's strongly typed like our other calls. And what we're going to want to do when we do join call centers is actually use groups, add to groups async. So this is going to require a connection ID, and this could be the connections that you know about, but what you really want is the caller's connection ID. And we'll get that from an object on the class called context, where we can just ask for the connection ID of the caller, and then we're going to give it a group name. And in this case, I will call it the call centers. And of course, this is async, so I'm going to need to put it a little await there. So a really simple call. We can now call into this. And why would this be interesting? This will be interesting because what we're going to want to actually do is change, instead of all here, is say, please send it to group call center. Or actually, let's make that centers, since it makes more sense. And so in this way, we can specify groups or even individual users to call. So you could imagine here, we could also do clients user to get an individual user ID, others, which would send the message to everybody but the caller, which is often useful, and also caller to be able to send just to the person that is making this call into the hub. So you have a few different options there, but we're going to use the group. And we also have to duplicate this because remember, this call isn't called unless it's called from a client. So over here in home controller, so we're going to want to change this from all clients to just the group called call centers. And so you can have a different way of sort of mix and matching the different pieces that you want. Now, one approach that you'll see sometimes is that they'll wrap the call center hub inside of another class that sort of hides some of these details for you. But in many cases, you don't need them hidden. I'll leave that to architecture experts to go ahead and decide what that needs to look like. There's a lot of good examples of that out on the web. But here we should be able to just have the call centers actually be called. Our app isn't actually going to change a lot. But now, once we refresh them, we'll be able to go ahead and get a call from Jake. and it should still work because we're sending this only to the call center people and we're getting it here. So if you need to segment the messages to certain groups of people, you do not need to do it necessarily by creating separate hubs. You can certainly have different groups. You could imagine that you might want, if you were building something like a simple chat app, you might have every room in their own group so that you can have people in individual rooms chat just to each other or only in one-to-one conversations between two people. So you can really build this up to be not just multicast to an entire group, but to small groups or really large groups as well. Let's wrap up this micro course. So let's see what we've learned so far. I've shown you how to use SignalR in your ASP.NET Core projects. This means SignalR supports building server notifications to a variety of different clients. This is an abstraction over WebSockets or the other transports so that you can do simple remote procedure calls. Some people like to think of SignalR as RPC or remote procedure call. I like to think of it as more like messaging. These don't replace traditional APIs that you would build as RESTful services, but they do fill a gap where you need to support multicast and notifications to a number of clients from a single call. And SignalR scales out easily. So SignalR will work on one or a series of servers, whether you're in the cloud or hosting your own. So thanks for watching this micro course on SignalR and ASP.NET Core projects. I'll see you in my next course. Thanks again.